Talking about the product rule of exponents. Another rule that comes into play when dealing with rational expressions and figuring out what to do with our exponents. So I'm going to look at these three basic problems on the left side, and then we're going to take what we learned from over here and plug it into a more complex problem over here on the right side. So starting with our first problem, 4 to the 5th power times 4 to the 3rd power. I'm going to break it down for you so you understand why this works. Here we go. 4 to the 5th power means 4 times 4 times 4 times 4 times 4, 5 times. And they want us to multiply that by 4 to the 3rd, which is 4 times 4 times 4, 3 times. So all of these 5 4s being multiplied together by all of these 4s being multiplied together gives us a grand total of 5 plus 3. And that is the rule. You just say 4 to the 5 plus 3. When your bases are the same, 4 and 4 in this case, we add our exponents together if we're being asked to multiply. So you can see that I have 5 down here plus 3 more, which would give me a grand total of 8 4s. So our answer is 4 to the 8th power because 5 plus 3 equals 8. Now, if we go down here, the only difference between this problem and this problem is now we're doing using a variable, z to the 7th times z to the 5th. That means we're going to have 7 z's being multiplied times 5 more z's. So all we have to do is say z to the 7 plus 5. We add 7 and 5 together, and we get a grand total of z to the 12th power. So here we have our first two answers. Now, we go to this third problem, which is slightly different. We have coefficients in front of our variables. But if you look, we're dealing with an m and an m. Our bases are the same. So we're going to first take our coefficients, -4 and +6, and we're going to multiply those together. So 4 times 6 is going to give me 24, but a negative times a positive gives me a negative 24. So I write that down. Now I'm going to focus on just the m's, m to the -3rd times m to the 5th. So I'm going to say m to the -3 plus 5. -3 plus 5 would give me a 2. So my final result here, the most simplified that I can take this expression down to, is -24 m to the -3 plus 5 gives me a +2. So -24 times m squared is what you get there. So here are three fairly basic examples of these problems. And now we're going to take that idea and move it over here where we're dealing with something a little bit more complex. Best way to do this is break it up into parts. Look at the parts that match. So if we're multiplying everything together and we have two different a's, I really just want to focus on those two a's as their own thing. So let's just focus on the a's for right now. We'll forget about every other part to the problem. So I have a regular just a by itself. Now, one thing we don't show is if it's just a term, or excuse me, a variable all alone, we know there's a 1 up there, we just don't show it. So we need to think of this as a to the 1st power times a to the 3rd power, and we're going to add that 1 and that 3 together to get a to the 4th power. Now we're going to focus on just the b's. So I'm going to take another color here, orange in this case, and I'm going to put an orange underneath the b and the other b. All I'm focusing on at this point are my b's. B to the -1st and b to the 4th power. So I need to say b to the -1 plus 4. And we know -1 plus 4 is going to give me a +3. So I can write that down. So right now we're almost done. Now we just have to focus on our c's, and we also have that 7 over here by itself. So I got c squared times c to the -1st. I'm adding these exponents together. 2 plus a -1. Adding a negative is really subtracting. So we're actually going to get c to the 1st power. But notice I did not write down the 1. 2 plus a -1 gives me 1. I have no reason to write that down. C by itself is c to the 1st power. So far we are almost done, but we have this 7 as well. 7 did not have a number over here that it was being multiplied by. Now, if there was a 3 right there in the front, we'd multiply the 3 and the 7 together and we would get a 21. But instead, I have nothing to multiply that 7 by, so I'm going to take it and I bring it all the way over here to the front because you always want the coefficient at the start of the term. So I get 7, a to the fourth, b to the third, c as my simplified rational expression. Real quick, a to the first, a to the third made a to the fourth. B to the negative first, b to the fourth made b to the third. C squared and c to the negative first made a c. 7 had nothing to multiply by, so it ends with 7. Hopefully this all makes sense. This is the product rule being put into place right now. One more thing that we could think about as we go on is if you were to end up with any negative exponents, you would put that on the bottom of a fraction, because we all know from watching my previous videos, you can't end up with negative exponents. It's not allowed, so you need to move it to the top or the bottom based on where it starts. Hopefully this makes sense. If it did not, or you have any struggles or confusions on what I showed, please make a comment or leave a comment, and I'll try and get back to you and help you through whatever misconception it is that you have. All right, you guys can do this, and good luck on your upcoming test.